Hi, everyone. This is Aaron Larson, executive editor of Power Magazine, and you're listening to the Power Podcast. On today's episode, I'm joined by Ben Burke. He's the CEO of Gradient Geothermal. So, Ben, thank you so much for coming on the program. Please tell a little bit about yourself and what Gradient Geothermal does.
Aaron, thanks for having me, and very excited to talk about Gradient Geothermal's approach to geothermal. So we're a company that manufactures, leases, and sells modular geothermal equipment for the oil field, for geothermal operators, and potentially for data center clients. What makes us different from typical geothermal or traditional geothermal is the modularity and the mobility of what we do, which allows clients that flexibility where moving the equipment every 6 to 18 months is important, but also the ability to move equipment on and off site as their thermal load changes. So we can bring 10 units to a site, we can reduce that to 5 or increase that to 15, really as a client's situation changes.
Can you talk a little bit about the technology and what makes it different from other types of geothermal power generation approaches?
So our equipment really comes in two parts. The organic Rankine cycle unit, which we buy off the shelf from any variety of makers, and then a primary heat exchanger loop, and that conveys heat from the flow line, which has sand. It can have all sorts of brines and minerals in it, dirty water in general, conveys that heat from the flow line over to the ORC, which demands very clean water. And being able to put those two together, have them work in what are known as class 1 div 2 spaces, meaning areas where there's potentially hydrocarbons in the water and a potential flammability concern. We can take any ratio of oil, gas, and water, convey heat from that, and allow the operator to either have power from that or have power and cooling from that as well.
And what kind of scale are we talking about? I mean, how many kilowatts or megawatts are you able to generate from a typical well?
A typical well can be anywhere from the minimums to the maximums of our unit, which are 75 kilowatts, 150, and 300 with the current setup that we have. It's really all about how much hot water and how much flow an operator brings to us.
Mhm.
We're generally about 10% efficient in terms of taking thermal kilowatts and translating those to electric kilowatts.
What do most of the companies that come to you to implement this type of a solution, what are they using that power for? Is it typically just for well pumps and other things out near the site, or are they actually able to connect to the grid and export power that way?
So all our clients are grid connected, and the equipment does need a grid connection to function. That said, the power usage is generally used on site with pumps and whatever electrified items they have on site. That said, a lot of our operators tend to find the most value in the cooling service because we tend to come in cheaper than the incumbent solution of fluid chillers that simply only consume power from either a generator or the grid. And here they are able to get some power back or be power positive, depending on their situation.
I'm not very familiar with oil and gas solutions and how they operate. Are you typically coming into a situation where there are multiple wells owned and operated by a particular company that's implementing the solution, and they're using one well to do this, or are they putting this on every well that they operate in that little region or area?
I can answer that question two ways. One, in some places where the individual wells are rather high flow, we can work at the wellhead. That way, you tend to get the highest temperature and the most power generation for the volume of water. In other places, the individual wells just don't have the volume of water that support power generation, but the temp is there. So aggregation tends to be the game that we play alongside our clients to figure out where the most optimal location is. So we tend to be on pads at the point after flows are aggregated, but before they go into a midstream pipeline.
Mm. And you made a point about this being modular technology and mobile. What advantages does that provide when you're deploying or operating these systems?
The advantage of mobility and modularity is really important to oil and gas operators. Many of our clients have the need for our services on new pads, and these new pads have a slug of water that comes back in the first 6 to 18 months, depending on the pad and the basin. And so every 6 to 18 months, our equipment's going to move to the next pad and to the next pad down the line. So we in a sense follow a drill rig, but with a delay. And having the equipment on trailers or having the ability to skid it around is really important because these small moves are only a mile or so between pads. But having them on wheels, having the ability for a forklift to put them right onto a trailer makes things very easy for the operator.
How long are they typically installing these on a particular well?
Well, glad to clarify. So we have really two different kinds of deployments. One are deployments at mature oil fields where the amount of flow and temperature is pretty stable over time. There, the modularity allows for very quick installation, but it can be effectively seen as a permanent installation in those cases. In the case of these new pads that I'd referenced earlier, that installation tends to be a 6 to 18 month period of time. Installation takes one day, whether these are skidded onto site or trailered onto site. So we like to say it's two pipes and three wires,
Mhm.
and it's able to sit on a gravel pad or sit on the trailers. And then when it comes time to move them, it's unhooking them in the course of one day and moving them along. It's really all about the amount of time an operator would have the need for the incumbent solution, which is a fluid chiller.
Do most customers come to you, or how are you getting the word out about this solution to the oil and gas companies and getting it installed on different wells? How do you find these potential abandoned wells or wells that need this solution?
The wells that need this solution are a combination of new wells that are being freshly drilled and older sites. In general, a lot of people call us. They find us on the internet. They hear us speaking at conferences, either around Denver or internationally, and so reach out to us via those means.
Hmm.
We don't have a sales team. We have quite a backlog of clients at this point, but we're busy expanding and excited to talk to new clients.
And I understand the process also includes plugging orphaned wells after the energy is extracted. Can you kind of talk a little bit about that and what sort of environmental benefits are achieved through that process?
So we work with one of our sibling companies called Zafiro Methane in our sibling company through our lead investor, Ex Machina Capital, and they're the company that does carbon credit generation for orphan well and abandoned well plugging. And so we work in tandem with them to bring that service out. So where we can extract any heat from a well for that life of the well, and in some cases, extracting simply heat through water from the well extends the life of the well. But when its service life is over, and if all the heat is extracted, in some cases heat can be mined out of wells, and it is a temporary life to the well, and in some cases we can modulate the flow such that it's a truly renewable resource, and the well never runs out of heat.
I guess that was going to be another question I have is there a way to use this more as a long-term energy provider and maybe in other applications where it's not necessarily being used on an abandoned well or to remove heat from a well, but maybe from other geothermal resources? Do you see this expanding into other areas, or is this kind of your niche and you're just kind of focused on helping these oil and gas companies remove the heat from these wells that they need to do?
We can work with really any flow stream from any sort of well, not necessarily an oil and gas well. So we've been expanding. Geothermal companies have started calling us recently, and we've been expanding into the geothermal market. And we can do that in a sense because the modularity and the portability and the rapidity with which we can set up these units stands in contrast to the amount of time it takes to build a permanent multi-megawatt power facility at a geothermal site. And so we can come in with a well testing solution and a small multi-megawatt power gen solution, while the large, say, multiple 40 megawatt plants at some larger places are taking their years to be built. But there's no real time frame or sunsetting to the opportunity behind pulling heat and making power from these wells. A lot of it's around the concept of heat mining, which is the idea of kind of cooling off the area around a well. And that happens if you're putting your cold water back into the ground too close to where you're pulling the hot water out of. And so we work with clients to optimize their water injection such that it's happening, say, at least a mile from where the hot water is being pulled out of the ground. That way, the earth itself has a chance to reheat the water back to its normal temperature. And so in that case, then we're cycling hot water or recycling water through the ground and using the ground as and the reservoir as a heat exchanger. And in that sense, then they'll heat is the renewable resource and it will never deplete.
And you mentioned that there's a lot of, I don't know if you would call them contaminants, but you said sand and some other things that come up with the water that you have to kind of separate from the clean side where the energy is generated. Are you able to filter and process and improve that water in some way, or do you even need to? Is that a concern of yours at all?
The chemistry of the water is the naturally occurring chemistry that's there. So we wouldn't call the materials in the water contaminants. We don't have to do any separation or cleaning of the water to make it useful for us. We can heat exchange with it in whatever state it is. And that water then just goes back into the ground. In the case of working with an oil and gas company, uh, we we don't have to do anything with the water except extract the heat out, and the oil and gas company can continue to handle that water in the manner they always have,
Mm.
whether that's reinjection or disposal through other means.
And I was reading some information on your website, I believe, about the ability to recycle water and how this could actually be important for certain things like data center operations, for example. Is that something that you're focused on? Because obviously data centers are really important in our audience. They're talking about the growth of these AI-enabled data centers and how much power that's going to require. Is that another area that you might branch off into?
We're exploring the data center area actively at present. We don't have any operations there at the current moment, but we're excited about the idea of both rejecting heat to the air and to the ground, so that putting the geo and geothermal for data centers. Data centers tend not to run at temperatures or have their liquid cooled effluent, if you will, running at temperatures that intersect with the opportunity for power generation. And so we would be bringing simply a cooling solution to data centers rather than a power gen.
Mm.
But where data centers do bring hot water, hot enough to make power generation functional, then we're glad to do that. When it comes to powering a data center from a primary sense, data centers take hundreds of megawatts. I think gigawatt data centers are on the horizon. And so our small modular solution is not really feasible in terms of powering a very large data center like that. That would be more feasible in terms of powering what can be known as edge computing centers, switching centers, but smaller, very small data centers that effectively take 1 or 2 megawatts
Mm.
of power. That would be appropriate though for powering the our solution.
And you mentioned a lot of, or at least some of the components that are used in your system are off the shelf from companies that you buy them from. Do you then bring all of this together and build the units in Colorado, for example, and then ship them places, or how does that process work? Do you build on site, or do you have like an actual factory where you're putting these together?
So we don't own our own manufacturing at this point. We do buy the ORCs, the organic Rankine cycle units off the shelf. We put those onto a ruggedized skid as well as enclose them to make sure they're able to work in hot conditions in the summer and cold conditions outside. Our second skid is something that we contract manufacture here in Colorado and Wyoming. So we do mate the two skids together and test them together here in the Rocky Mountain area. before shipping them off to wherever they're going, whether that's towards the East Coast or further west or southern points.
Mhm. And I understand you've got some of these already deployed in Colorado and North Dakota. Can you talk a little bit about those locations and how those projects are functioning and any challenges that you might have faced in getting them out there and deployed?
Our first project site was a pilot project at a small oil and gas site, mature oil field, oil and gas site in Nevada. That site we ran actively for about a year and a half, and that was being our pilot site. We learned a lot there about continuous operation, where the variability and availability of client water affects our ability to cool and affects our ability to generate power. So we learned a lot there, and then deployed that unit into a commercial project with Chord Energy up in the Williston Basin of North Dakota. And we're excited to say that Chord has recently re-signed with us for additional projects. We have another commercial project starting up in the Haynesville of northeastern Texas and western Louisiana here this summer. That is primarily a gas cooling project. So through our pilot, which was a liquids cooling and power gen project, we were able to re-engineer and additionally engineer our equipment to handle power generation from gas as the thermal media. And we have other projects coming online later this year in Colorado, and then potentially overseas as well.
Are there any regulatory hurdles to implementing this, or is that not really a big concern?
It's regulatory is not a big concern from an oil and gas standpoint, where the power is exclusively used on site. Of course, different oil and gas regulations, or oil and gas regs differ state to state, and whether you're on federal lands or not. But it tends to be simple, just like filing a piece of paperwork to bring a diesel or natural gas generator on site. We can be thought of as a power solution that is a generator running on hot water. When it comes to truly geothermal side of things, clients have to make sure that they have geothermal rights to the subsurface. And those vary by state as to whether they are conveyed with the surface or are considered a mineral in the subsurface or considered a water right. So different jurisdictions certainly handle that differently. But in any case, those are usually sometimes conveyed alongside oil and gas, minerals and leases, and in some cases, leased separately.
Mhm. Are you working on any improvements to the system, technological improvements that might make it more efficient or could expand the applications in any way?
We're working on pushing the boundaries of our thermal envelope, if you will. Right now, we can make power when the fluid comes to us at least 150 Fahrenheit and as high as 302 Fahrenheit. We're really excited on working on innovations in the low end, so we can accept temperatures in the 140s, potentially even the 130s, which will further expand the number of wells and the number of fields that would be applicable for this technology.
Do you have like an estimate of the difference percentage wise of wells that are available today that meet your criteria to the wells that would if you were able to operate at these lower temperatures?
So, with the current technology as it is, we estimate that about 500,000 wells in the U.S. Fit the temperature profile for what we do, and from that, there's the potential for about 13 gigawatts of power to be made, if all of them theoretically could be put to use. In lowering our threshold by 20 degrees or so, that would bring our total closer to 800,000 wells, and so that's a fairly significant broadening. But again, in many cases, multiple wells with the correct temperature can be brought together for the minimum or adequate flow rates needed. So it's still a mix and match game, even as temperatures get lower.
And what's your vision for Gradient over the next 5 to 10 years? Do you see this really taking off, or are there things that are holding you back from large scale deployment at this time?
Right now, we've been working with customers getting initial deployments out the door for them, and they're interested in seeing how the equipment works within their operations and their facilities. But our goal is to grow with our client base, both replacing the incumbent fluid chillers which allow our clients to have a 10 to 20% savings on their fluid chilling, as well as providing, when you start getting to scale, multiple megawatts across individual clients' assets or their portfolios. So we're excited to grow with our clients and start providing a meaningful both cooling and power gen solution for them, both here in the States, but also in projects we're working on in South America and in the Middle East.
Well, Ben, this has been interesting. I've enjoyed learning about the technology and what you're doing. Is there anything that we haven't talked about that you feel might be important to touch on before we wrap up the podcast?
I think you've covered everything pretty well. I can say when it comes to the modular nature of what we do and the fact that these can be Lego together. So where we have clients that have, say, very hot water, we can pull some temperature off with one unit and have a second unit in series behind it, and a third and a fourth if required. And if clients come to us with very high volumes of water, we can run individuals or these series in parallel. So we can functionally handle any volume of water and any set of temperatures. And it gets really exciting when you have multiples, or as we do have plans for, have multiple series of these in parallel. And then you start to get to, at individual sites, start to get to multi-megawatt power gen opportunities and a lot of cooling load as well that would otherwise consume hundreds of kilowatts to potentially megawatts off the grid. When we work with utilities as part of this process with our clients, they're very excited to have us bring the solution to their utility grid and allows them to achieve greater resiliency within the grid because they're not getting high loads popping up in oil fields, which tend to be at the very end of the line power wise.
Mm-hmm.
So it allows for it's a solution that allows the regional utility to achieve that greater grid resiliency and not just benefits to our direct customer.
Again, for listeners, I've been speaking with Ben Burke. He is the CEO of Gradient Geothermal. It's been a pleasure having you on the show, Ben.
Thank you, sir.